Okay, recording now. We're going to go over the paper today that you did yesterday. What I'd like you to do as we're going over it is to mark what you've done, because I'm going to ask you to have a go at sort of marking your work, and just so you can see what where your strengths and weaknesses are, ready for a full practice on Tuesday. So on Tuesday you will have a full practice that I will ask you to submit to me for my marking. So this just gives you a bit of a practice. Okay, so I'd like you to sort of just mark as we go along. Once the live part of the lesson's finished, obviously then your task is going to be to add up your marks out of 75. And if you send it to me in the comments from this lesson, I will then mark you as having engaged with the lesson. If I get that by the end of the day on Friday. And what I'd also like you to do over the weekend is really have a look at the topic areas where you maybe struggled with the questions. I know I had a couple of papers were submitted to me already, which is great. Thank you very much for that. Where you've got that, hopefully you've got your feedback, you've got my marking, you can see how well you did. I'm actually really impressed by the number of people that have really done well here, even though I need a couple of submissions. It was optional to submit it to me. So I'm actually really impressed by your dedication, but also by the actual outcomes here. So we're going to go through this. I'm going to do almost a walking, talking mock with a discussion of marks as we go over it. So obviously we've got the formula sheet, and then we've got question one. Question one will always be pretty much the same, in that there'll be some data and it's all about manipulation of errors and units. So the first thing to do is to suggest the uncertainties or the sensitivity of the stopwatch and the tape measure, and you're looking at your number of significant figures here. So here the stopwatch is measuring to the nearest tenth of a second. So the answer is plus or minus 0.1 seconds. And the tape measure, being used to measure distance, because it tells you in the question that they use a tape measure, is, well, it's the nearest centimetre. So plus or minus 0.01 metres. In order to get the 1 mark, you've got to get them both right to get 1 mark. Okay. Then you have to calculate the mean time taken to reach the end. It's only 1 mark, so I'm not requiring working on this. You can either put it up here or down here, but if you work out the average, it comes out to be 2.03. If you wrote 2.0, that's absolutely fine. Either answer would be acceptable, and that would be worth a mark there as well. Then you have to calculate the percentage uncertainty in the pupil's measurement of the time taken to reach the end. I'm just aware that my focus has gone a little bit out because the heating's come on and it's changed the room temperature, and it affects my focusing. So the percentage uncertainty in the pupil's measurement of the time taken. Again, it's fairly simple. So their absolute uncertainty, remember, is the range. Whoops, blue pen. What you should write is the range over 2, which is going to be your highest and lowest values. So the highest value is 2.2, the lowest value is 1.8. 2.2 minus 1.8 over 2, which is 0.2 seconds. Okay, so that's your absolute uncertainty. To get the percentage uncertainty, you have to then divide that number by the actual value. So to get the percentage uncertainty, to get the fractional uncertainty first, it's 0.2 over the mean time, 2.03. Again, if you use 0.2, that's fine. Sorry, 2.0, that's fine. So it's 2.03. And when I did it, it came out to be about 0.098, which if you multiply it by 100, because I want the percentage uncertainty, comes out to be 9.8% was the correct answer. Again, I accepted it if you said 10%. That's absolutely fine. Either one of those will do. It was 1 mark for more or less the correct answer, and 1 mark for showing that you knew how to work out the uncertainty in the values. I'm just going to readmit somebody there. Okay. Oh, we've got 2 Sheilas. So the first mark was really for calculating the absolute uncertainty of being 0.2. The second mark was for that. As I said before, please self-mark as we go along. If I'm going too fast, or if you don't understand something, or you're not sure whether or not an answer that you wrote was correct, please let me know, and I will I can sort of stop and explain it. Okay, but if you don't let me know, then I don't know to slow down. Okay. Now the next part says the pupil uses the formula to calculate the acceleration. So there's a little bit of rearrangement required. So A equals 2d over t squared, always showing our working. And so then you substitute 2 times the distance, which is 2.1, it's in the table, divided by t squared, so that's 2.03 squared, comes out to be 1.02 meters per second squared. Now the question says, sorry, did somebody ask you a question? No, okay. So the question is 2 marks, and it says giving the correct unit. So you get 1 mark for the unit, even if you got the answer wrong, and 1 mark for the correct answer. Okay. Now, if you use 2 instead of 2.1, that would come out to be a slightly higher number, which is absolutely fine. But it's this bit that I'd be looking for, really, is the rearrangement and the substitution. So the next part, calculate the percentage and absolute uncertainty in the pupil's measured value of the acceleration of the ball. Now, with the submissions I had, this one, quite a few of the times, I wrote this symbol, which is Bod, which means benefit of the doubt. So when you submit an answer where I think you kind of got it right, but I'm not entirely sure, but I think I'm fairly certain you got it right, really, then I'll give you what's called the Bod Mark. Okay, you get a mark, you get the marks anyway. But this is a 4-mark question, so you know you've got to set out some working, and you know that you've got to produce some kind of detail. In this case, 2 particular answers. Okay, this actually requires 2 answers. So again, you can do this by working out the range of values and divided by 2 to get the absolute uncertainty, and calculating the percentage uncertainty afterwards, or you can calculate the percentage uncertainty first and then get the absolute uncertainty. So if we want to work it, if I do it algebraically, it is my favorite way of doing it, just makes more sense. We've got d over t squared. So we want to add the percentage uncertainty of d. So that's the uncertainty, that's the percentage uncertainty, well, it's over t squared, so it's 2 times the percentage uncertainty in the time. Okay, that sigma t means percentage uncertainty, it means uncertainty. So we substitute, well, we don't know this value, but we do know the uncertainty in the tape measure is 0.01 meters. So that's going to be 0.01 divided by the length, which is 2.1, plus 2 times, well, we know the percentage uncertainty, and you know that if you use that value, even if it's incorrect, you will get your, you notice that you will therefore get, you get your error carries forward marks. So my uncertainty was 9.8%, okay? So it's 2 times 0.098. Again, if you put 0.1 there, that's absolutely fine. You end up with a value of 0.2008, which is a percentage uncertainty. So that implies 20% uncertainty. Okay. So once you've implied a 20% uncertainty, I'm going to double underline that because it is one of the answers I'm required to give. The next part is to then work out the uncertainty in the acceleration. Well, that's going to be the percentage uncertainty multiplied by my value of acceleration. Well, that just comes out to be 0.20 seconds. or 0.2 seconds is absolutely fine. And that's my absolute uncertainty. Okay, so you get 1 mark for saying 20%, get 1 mark for saying 0.2. If it didn't see the 20%, but I saw that, then I'll give you the mark for that instead. To get the other 2 marks, the 1 mark is for showing that you know how to actually calculate the uncertainty, whether you use the range method or whether you use the method I've just demonstrated. And then your 4th mark is for then showing that you know how to turn the percentage uncertainty into an absolute uncertainty, or vice versa if you use the range method. Okay, but basically, if I'm marking it, I'll be looking for these 2 numbers. If the working isn't absolutely clear, but I see these 2 numbers, you will probably get the Bod marks for the working. Okay, I'll give you the benefit of the doubt. You've clearly got it right, so you must have done it correctly. If you guess those numbers, then I'm, and got them right, then I might ask you to select numbers for a lottery ticket for me, because that'd be an incredible amount of luck. Okay, the student suggests replacing the clockwork stopwatch with a more precise digital stopwatch. Suggests will this improve the quality of results? Now this one, it's a little bit of a trick question, because you'd think, yes, it would improve it, but actually no, because what they've got is quite a range of times, and it's not caused by the stopwatch. It's caused by the fact they're manually timing it. They tell you they measure the time using a clockwork stopwatch. So it's clearly, although it'd be more precise, it's not going to be any more accurate, and therefore will not improve the quality of the results. So no, because that's why worth 1 mark, and it's because the random errors caused by timing methods are larger than the uncertainty. I'll explain what that means in a minute, because this is a question that not many people got right. So to explain it, if you look at the uncertainty of the stopwatch, it's plus or minus 0.1 seconds. If you look at the uncertainty of the time measurement, it's 0.2 seconds. It's twice as much. Now, if the uncertainty in the measurement was less than the uncertainty in the stopwatch, or very, very similar to it, then it might actually be worth looking at using a more precise stopwatch. But in this case, it's not the case. In this case, we've got a very large random error, which is caused by that manual timing. And it doesn't matter how precise your stopwatch is, your timing will still have the same level or very similar level of random errors. So basically, it was 1 mark for the answer. No, it doesn't. And 1 mark for an explanation. Now, if you said, yes, it does, and gave a very good explanation as to why you think it does, if there's some valid physics in there, you would actually get some marks, okay, because you're using valid physics to answer your question. So that's question 1. And in question 1, you need to put your mark out of 12 in that first bit on the front cover, or in a list somewhere, so that you've got a record of how well you did with that one. So if you did well with that question, then you're pretty good with uncertainties and units. Let's move on. Next one is the Newtonian mechanics, Newton's laws, and a little bit about energy, possibly, but it's really about being able to apply the basic dynamics and kinematics that I've taught you. So this one's all about a motorbike, and it contains data. There's a data table for the motorcycle, and you've got to be careful because there's an accelerating force and a braking force. So we've got to think about the fact that we need to make sure we're using the right one here. There's obviously only one engine, and that's the force provided by the engine. That's the force provided by the brakes. That's the top speed, 80 meters per second, which is pretty fast. And that's the typical mass of the motorcycle. We assume it's the motorcycle and the rider, okay? It's beware, in some tables, it'll give you the typical mass of the motorcycle and the mass of the rider or something like that. So you need to be very, very careful about that. So in this question, you have to show the maximum acceleration of the motorcycle is 2 meters per second squared. So that's using F equals ma. Rearrange it, A equals F over m. This is pretty basic, pretty simple. Now this is the acceleration, so it's going to be the accelerating force. 500 divided by a mass of 250, no brainer, 2.0 meters per second squared. Okay, the bit I'm looking for is actually this bit here, or this. Either these two will actually do the job quite nicely. So if you showed this, either this or this, and you're working, you get a mark. You don't get a mark for the answer because it's already stated. But you know if it's stated, you're going to have to use it. So the motorcycle should say accelerates to top speed. Calculate the minimum possible time to accelerate to this speed. So we've got to think about our Suvat equations. Well, if you want to work it, so if we write Suvat, we want to know the time. We know the initial speed is 0. We know the final speed is 80 meters per second. We know the acceleration. We don't know the distance. So we're using the acceleration is v minus u, the change in velocity, divided by the time taken. Okay, so if that's the case, well, the time taken therefore would be the change in velocity divided by the acceleration. Substitute. So it's 80 minus 0 is just 80 divided by acceleration, which is 2, which means it would be 40 seconds. Okay, it's 1 mark for that 40 seconds there. Okay, it's either right or wrong. The next question says that you have to calculate the distance traveled while you're accelerating, while the motorcycle's accelerating. So when you calculate the distance traveled while accelerating, we want to think about our Suvat equations again. Whoops, change pen. S-U-V-A-T. We're not bothered about the time. We know the acceleration. We know the initial and final velocity, and we want the distance. So it's going to be v squared equals u squared plus 2as. It's the only Suvat equation that doesn't involve time. So if that's the case, then we've got, we know that we want to work out the distance. So s equals, well, it's v squared minus u squared, rearrange, over 2 times the acceleration, which we know. Substitute, well, it's going to be 80 squared, u is 0, so we just can ignore it, over 2 times 2 meters per second squared. It's quoted in the first part of the question. So if that's the case, well, that's 80 squared over 4, which is 1,600 meters. Okay, that's the final answer, double underline, so I can see your final answer. You get a mark for the answer and 1 mark for identifying the correct Suvat equation in this case. The next one, if the motorcycle travels twice this distance before reaching top speed, calculate the actual average acceleration of the sorry, I'm just going to turn my email off because I'm just getting constant. There we are. Sorry about that. I was just getting hundreds of emails coming in. It was distracting me. So the motorcycle travels twice this distance. So again, it's Suvat, and it's going to be the same formula. But this time, we want to get the acceleration. So the acceleration is v squared minus u squared over 2s. It's twice the distance, so it's twice that value, it's twice this value, and the area does carry forward. So it's 80 squared over 2 times 3,200, which gives you 1.0 meters per second squared. Significant figures aren't important in this one, but the answer of 1 is worth 1 mark. And it's 1 mark for correct substitution into the formula here, okay? Including doubling your distance, whatever your distance is, which is why working is so important. So the motorcycle's got a top speed of 80 meters per second. Why does the motorcycle have top speed? Well, it's the idea about balanced forces. So we start with 2 mark questions, so we want a little bit of detail. So we start off with the idea that friction and air resistance increases with speed. Okay, and that will be until they are equal to the force from the engine and transmission, just say engine, and that implies no net forces, no net or resultant force. Okay, so it's the idea that it's identifying that the friction and air resistance become equal to the driving force from the engine, and the fact that that means that there are no net forces anymore, it's in equilibrium. It then says, show the theoretical maximum power output from the motorcycle is 40 kilowatts. Well, this is an easy one. P equal power is force times velocity. So force is 500 newtons. Velocity is 80 meters per second, which comes out to be 40,000 watts, which is equal to, well, 40,000 is 40 kilowatts because a kilo is 1,000. So the mark is for identifying them using P power is force times velocity. The other mark is for then doing correct substitution, and then you get your 2 marks from that. Okay. The next part is to estimate the distance the motorcycle could travel using 1 kilogram of fuel. State any assumptions that you've made. So we need to know the idea that, well, we're going to make an assumption first. We're going to assume it's 100% efficient. Of course, petrol engines are not 100% efficient, but we're going to pretend it is. That's going to be our assumption, because we can't really do it unless we do assume that. So that's worth 1 mark. So you want to know the idea. Well, got to think about what we're going to use. Well, the work done is the energy transferred, which is force times distance. Okay. And so we work out the distance traveled. So we want to work out the distance, that its range, its distance. That's the work done divided by the force, which is equal to, well, the work done is in the data table on the front here. 1 kilogram of fuel is 4.5 times 10 to the power 7 joules per kilogram. Okay. Divided by the force of 500, which gives you 90,000 meters, okay, which is about 90 kilometers. Okay, so that's worth 4 marks. So 1 mark for saying that that we're assuming it's 100% efficient, 1 mark for identifying that you need to use force times distance, 1 mark for substitution, 1 mark for the correct answer. Then part D is all about looking at estimations and reasonable values. Well, explain whether or not your estimation is a realistic value for the distance traveled using 1 kilogram of fuel. Well, it helps to sort of estimate that if you've got 1 kilogram of fuel, if it's got a similar density to water, then that's 1 litre of fuel. It's a little bit less dense, so maybe it's a tiny bit over 1 litre, but it's not going to be much more than 1 litre. And it's saying it travels 90 kilometers on 1 litre of fuel. That's not really realistic. So no, okay. And the best reason you can give is we know that the engine is not 100% efficient. So the actual distance will be less. Okay, so 1 mark for saying the engine's, for giving a reason why you don't think it's realistic. 1 mark for identifying that the estimated distance is far greater than the distance it would actually travel on 1 kilogram of fuel. Now, I shortened this question because I wanted to sort of make the paper a little bit shorter for you. The motorcycle stops using the maximum braking force and comes to rest from top speed. Calculate the distance traveled whilst traveling. So that's SUVAT. We don't have a time. We don't have acceleration, but we can work it out. We know the initial velocity and the final velocity. That's 80. That's 0, and we know that we want to work out the distance traveled. So we need the acceleration. Well, the acceleration is simply force over mass. This time the force is the braking force. Okay, so we end up with an acceleration of -6 meters per second squared. Okay, so that gives you your acceleration. Now we do that, we can use v squared equals u squared plus 2as. Again, very easy. So s is going to be v squared minus u squared over 2a. So v squared, well, final velocity is 0 minus 80 squared over 2 times -6. Remember, it's negative because it's deceleration. And you end up with 500. When I calculated it, I got it to be 533 meters per second. Sorry, meters, not meters per second, I'm reading the wrong bit. Okay, 533 meters. So marks, well, the first mark is for working out the acceleration is -6. If you didn't have the minus, you'd still get the mark for that. 1 mark for correct substitution into the correct SUVAT equation, and 1 mark for calculating the distance. There are other ways of doing this question. Any method that is correct will receive marks. Remember, when I'm marking exams, I'm assessing somebody's ability to do the physics, not just somebody's ability to do the physics in the way that I've taught them. Okay, so that's out of 19. So that would go on your front cover, out of 19. So that would go, oops, oh dear, drowning in paper now. That would be out of 19. Okay. And on to the next question. Now, you've seen this question before, but this one's a little bit different. Be careful. The teacher demonstrates a method for determining the speed of a bullet. So they're showing the apparatus. When the bullet hits the block, it becomes embedded in the block, and the block and bullet swing upwards to a maximum height, h. So again, you've got your values for the mass of the bullet and the mass of the block. You've got your height raised by the block, and you've got your gravitational field strength, even though that's on the front cover anyway, in the formula sheet anyway. So the combined mass of the block and bullet is 1.99 plus 0.01, so 2.00 kilograms. That's just worth 1 mark. It's either right or wrong. Calculate the gravitational potential energy gained by the bullet and the block. So that's going to be mgh equals a mass, which is 2 multiplied by 9.81 multiplied by h. Now be careful, 305 millimeters. 1 millimeter is 1,000th. Okay, so that would be 305 divided by 1,000, which gives you 0.305 meters. Okay, so we've converted millimeters into meters, and then you just get your final answer, which I made to be 5.98 joules. Okay, 2 marks. 1 mark for correctly changing it to to meters there, and 1 mark for the correct answer. If you got the wrong answer just because you didn't correctly change to meters here, you may get 1 mark if your working's really clear. So then it says, assume 100% of gravitational potential energy of the block and the bullet came from its initial kinetic energy just after it was struck by the bullet. Calculate the initial speed of the bullet. Now, got to be careful here. because you've got to actually do a bit of a long calculation. This is a tough 2 marks. So first of all, we know that the kinetic energy would be a half mv squared. So that v is going to be the square root of 2 times that energy over m, which is going to be, well, it's 2 times 5.98 over 2.00, which would give you 2.45 meters per second. Now, if you wrote that as your final answer, I was generous this time, but you have to read the question. It doesn't want the speed of the bullet in the block, it wants to know the speed of the bullet. So what you've actually got to do afterwards is think about momentum. Well, if you've got 2 times 2.45 is your momentum before, because it's 2 kilograms times 2.45, it's going to be equal to 0.01 times by the speed of the bullet. So in other words, it's going to be 100 times 2, so that's going to be 490 meters per second, okay, because I've got to divide both sides by 0.01. And that comes out to be 490 meters per second. And that is actually your final answer. Oops, sorry, go for red. So you get 1 mark for final answer there, 1 mark for calculating the interim speed there, okay? Normally this would be a structured question, but I thought I'd throw this in as something a bit more challenging because you've done something similar to this before. So that one is out of 5. And in a real exam, if you get a question like that, remember that is the marks that would be awarded really to sort of identify distinction level candidates, okay? You should be aware that some questions will be hard, particularly if you're not aiming for a distinction. Now, number 4 is your graph question. Very, very similar to what I demonstrated in my walkthrough earlier on this week. So I'm just going to submit the answers. So if I've got to square my horizontal distance, it's 0.48, 0.56, 0.64, 0.72, and 0.79. All my numbers here are 2 significant figures, so my calculations should be rounded off to 2 significant figures as well, okay? So you get 1 mark for having 2 significant, oops, switch to red. 1 mark for having 2 significant figures, okay? You get 1 mark, you get 2 marks if you did all your calculations correctly. If one of these is wrong, you'd only get 1 mark. If you got more than 1 wrong, you wouldn't get either of these 2 marks. But even if you got them wrong but put numbers to 2 significant figures here, you would actually get the mark. You'd actually get the 1 mark. So that's out of 3. The next one is using graph paper. Now, I'm not going to sit and draw the graph for you because that's just quite a lengthy task, and I've demonstrated that already to you in the previous lesson. But we're going to look at what the graph should look like and what sort of thing I would be looking for as your examiner. So if you draw your graph, here's one I made earlier, okay? We should be aiming for each square to be 0.1 on the values of d squared, because the highest value of d squared is 0.79, which is up here, okay? Oops, up here. And the lowest value of d squared is 0.08, which is down here. And again, similarly with the height, it's 0.1, 0.2, 0.3. So 1 square is 0.1 every time. So that my highest value is going to be 0.5. My lowest is 0.05. So my lowest value is going to be here. My highest value is going to be here. So I'm not wasting much of my graph paper. So you would get 1 mark for the scale. Now, what I'd be looking for in the scale, I'd be looking for a sensible scale, so don't go up in 3s or in sort of 7s or anything like that. I'd be looking for a scale which uses more than half of the graph paper. So I'd look from all my data points, from the bottom one down here to the top one right at the top here. It's just underneath my arrow here. Okay, I'll be looking at those two, and I'll be looking at how much of the graph paper you're actually using. You should be able to use more than half of the area of the graph paper. So if you did that, if you had a sensible scale, that was easy to read, and you did, and you used more than half the graph paper, you get your scale. Then you get your axes or your labels, height in meters, distance squared in meters squared. So that's worth a mark. Now, I would, in a submitted piece of work, I would actually check a few of these data points, but for your quick check, for expediency's sake, what I would do is you should see that almost all of your points should lie almost exactly on the line of best fit, except for the top one that might be a little bit off. But if it's on the line, that's fine. So if all your data points lie on that straight line of best fit, we're going to assume that you've done the plots correctly, plotted your results correctly. And your line of best fit needs to be a straight line because it tells you in the question, and it should go through most of the points in this case. So the line of best fit is worth the fourth mark. Every time your graph is marked, it is marked out of 4, okay? Okay? Every time. It's an easy skill and an easy 4 marks to actually get if you get used to doing it. So my advice is, I know some of you are a little bit reluctant to print out pages, some of you are a bit reluctant to get graph paper. I would say it's quite important, and I would get that graph paper and get your get that practice in, because it's an easy 4 marks. Next part of the question is to measure the gradient of the graph. You know it's coming next. So the gradient of the graph, you pick your convenient point on your graph paper, on your line, not your data points. It's got to be the line. So you pick your 2 convenient points, one at the top, one towards the bottom. Nice big triangle, and that's worth 1 mark. So your big triangle, whoops. So your big triangle would actually be worth 1 mark straight away. Your second mark was then for correctly calculating the gradient. Well, you're measuring your y1 against your axis. You measure y2 against your y-axis, x1 against the x-axis, and x2 against the x-axis here. And then what you then do is you show your calculation. So it would be y1 minus y2 over x1 minus x2. Substitute. In my case, it was 0.8 minus 0.11 over 0.5 minus 0.07, which comes out to be 1.60. Okay, or I'd accept 1.6 there. Okay, so 1 mark for correctly calculating your gradient. And what I'll be looking for is a number that would be similar to what the gradient should be. Okay, if it's not, then I'll go back and look at your method for measuring the gradient and check that you did it properly, but you just made maybe 1 mistake and lost 1 mark because of it. The next part, though, the bit that people forget, is giving appropriate units. Well, y is going to be in meters squared, and x on the x-axis was in meters, so that's equal to meters. So your answer is m. And believe it or not, even if you don't calculate your gradient, if you give the correct unit, you get a mark for it. So it's well worth writing something down. I always say with the physics exams, it's well worth writing something relevant, because you can get something, because you usually get something for it if it's relevant and works towards the answer of the question. It then says, it suggests that the formula shown below gives the relationship between horizontal distance and height, where v is the initial horizontal velocity of the ball, and g is the acceleration due to gravity. So you'd be given a formula. Well, on your graph, you know that you put d squared on the y-axis and you put h on the x-axis. So this bit here is the gradient. So the gradient is this constant bit here, because that v squared is the horizontal velocity, which, remember, with projectiles, if we ignore air resistance, is constant, and g is the acceleration due to gravity, which is also a constant. So it's 2v squared over g, and it's but That's not what the question's asking. It's saying use base SI units to show it's dimensionally correct. So maybe I've jumped a step here. So that's not relevant to the question. So I'll put a cross through it. The bit that I'm after here is to show it's dimensionally correct. So what I'm doing is I'm using the units. Dimensionally correct is the same thing as homologous. So that's going to be meters squared equals, well, 2 doesn't have a unit, v squared, well, v is meters per second, so you square it, you have meters squared, seconds to the minus 2, over multiplied by h, which is in meters, divided by g, which is acceleration due to gravity, meters per second squared. So the seconds squared cancel, and the meters cancel, and therefore it cancels. Okay, so to get 1 mark was recognizing the units of v squared and a and the acceleration. And the second mark was for then going through this process showing a cancellation. So it's quite important to do that. Right, doing very well. We've been going for quite some time now. So hence, use your value for gradient of the graph to calculate the acceleration due to gravity. So this is where we want to write it. Now, a lot of people think, well, I've already written it up here by mistake, and this is why I showed you this. You should always put a cross and rewrite it in the answer space. Okay, want to be absolutely certain. So we know the gradient is this bit here is equal to 2v squared over g, because v is constant and g is constant. And we want to find g. Well, g is equal to, it's going to be 2v squared over the gradient, to just rearrange the equation. And then we substitute. So it's 2 times, well, v is 4, so it's 4 squared over the gradient, which is 1.6, or whatever value you had up here. The error carries forward. The correct answer, when I did it, would be, there's actually 20 meters per second squared, which is surprising because we're expecting something more like 9.81 or 10, but that's the value we got. So that's the value you quote, okay? Because there's nothing in the questions that says that this was done on planet Earth. So the experiment was done on planet Earth. So it could have been higher, who knows? So you got 1 mark for identifying that that's your gradient, and then 1 mark for using that to get that to come up with an answer that corresponds to the values that you have. Okay, so if your gradient measurement was different, this number would be different, but you'd still get the mark. So I'm looking for this substitution in the calculation. Okay, now remember the graph question is out of 14. So remember the whole paper is out of 75. So your graph question is the best part of 20% of your paper. So it's well worth tackling. Some people look at the graph question, realize it's quite a lot of hard work and sort of skip it and go on to the next one. You only really do skipping questions if you are completely stuck. Okay, you can skip it if you don't understand it, but you've got to go back to it. Don't leave questions blank. Don't leave anything blank. Right, the next one, again, very, very similar to the demonstration paper that I showed you earlier on in the week. You had to put your 3 force arrows, the weight, the perpendicular reaction force of the board on the toy car, and the driving force of the motor. So there's the weight roughly from the middle. So I'm looking for a vertically downwards arrow. We know that the force from the motor is going to be parallel to the ramp. And we know that the reaction force is at right angles to the ramp. Okay, anything like that, you just have to show the approximate directions. I'm only after the directions. If you put the arrows in slightly the wrong place, I'm not bothered. So that's just not important. And it's 1 mark for each one. 1 for MG being vertically downwards, 1 for F being up the ramp, 1 for R being at right angles to the ramp. So then it says explain why the car is in equilibrium. There are a couple of different reasons for it. Well, you could say that all the forces are balanced. I would accept that. You could also, because the question's a bit ambiguous, you could also say that it's traveling with a constant speed, okay? Because it tells you it's traveling up there with a constant speed. So there's no acceleration. If there's no acceleration, that implies no net or resultant force. Okay, that's worth the mark. I'll also accept that all the forces in all directions cancel out or equal 0. Now the next one, if you've got a car with a mass of 5 kilograms, the board's tilted at an angle of 30 degrees. Calculate the force on the car due to the motor. So we're trying to find on here what this F value is. So what we're doing really is a right angle triangle. So we put our 3 right angle triangles together. Okay, remember that's a right angle. That's going to be the reaction force. I find it always helps to draw it. That's going to be the driving force, which is what you want. And that's going to be mg, or the weight of the car. Okay. So if that's the case, then you're just really trying to work out what F is. And it's a simple geometry question because we know that that angle there, it tells you, is 30 degrees. So if that angle is 30 degrees, then this angle also has to be 30 degrees by geometry. So if that's the case, we want to find the opposite when we know the hypotenuse, the longest side of the triangle, and the angle. So we know that the opposite is going to be the hypotenuse multiplied by the sine of 30 degrees. So if that's the case, well, m is 0.5 multiplied by 9.81 multiplied by the sine of 30 degrees, and we get 2.45 newtons as your final answer. It's worth 2 marks, 1 mark for recognizing that formula, 1 mark for the answer. Not that hard. It's very, very similar to the question, again, very similar to the question that that you saw in my walkthrough earlier on in the week. But it's an easy couple of marks if you followed that and remembered the technique. Right, this one is a little bit tougher. Again, very similar, but we've just made it a tiny bit more difficult. Now, there are lots of different ways of doing this. First of all, state the maximum force on the car. So if we draw a horizontal line across here, okay, well, it could be anywhere between 650 and 700. So I've said 670 newtons, roughly. However, as it says states, you'd have to show any working. However, I would actually accept anything between 650. Well, there's no way on earth you'd think that was 700. So I'd maybe say 690. Okay. So there you have a simple, there you have a little bit of estimation. So we know that we're going to be plus or minus maybe 10 newtons. So then it says, use the graph to estimate the total change in momentum of the car in its impact. It's always well worth stating that it's the area, because actually if you said it was the area or made an attempt to calculate the area, you actually get a mark. And there are lots of different ways of calculating the area. One way to do it is just to draw a triangle. If I draw a line to the top here and down here, I've got roughly the same area under the line here and roughly the same to the area above the line, very, very roughly. If I do the same over here, I reckon it's about like that. I reckon that the area of that triangle will do it. You could do it by counting squares. You can do it by drawing a different triangle. Any attempt to calculate an area is going to generate the correct answer here. So there's no one sort of absolute correct answer. But here, if the area is a triangle, it's a half base times height. Now, need to be a little bit careful. I reckon the base is going to be probably about, well, let's say 40. And here it'll be about, I'd say about 175 would be about there. So I'd say about 185 roughly, very, very roughly, okay? You could do it by measurement if you like. Remember, it's the technique, not the final answer, so don't worry too much about it. So 185 minus 40 is 145, and it's in milliseconds. So that's half times by the base, which is 145 milliseconds, so that's 0.145 multiplied by the height, which we said before was 670. So just got to calculate it. And now, because I've done this manually in front of you, I've got to do it again, even though I've got it on my mark scheme in front of me. 0.5 times 0.145 times 670 equals 48.575. Now, it's an estimation, so that's a ridiculous level of precision to give for an estimation. Remember, most estimations are 1 or 2 significant figures. So my estimation would be, well, it's probably about 50 Newton seconds is my change in momentum or impulse, okay? So I'm looking for the fact that you tried to measure the area and got a value somewhere in the region of 50 Newton seconds. If it was 52 or 48, doesn't matter, but you should round off to about 1 significant figure. It should be pretty much the same as mine. If you got sort of 30 or something like that, then that's a bit off. It's not really a good estimation. The last part then says, if the mass of the car was 50 kilograms, came to rest after the collision, estimate the initial speed of the toy car. Remember that 50 Newton seconds is the change in momentum. So therefore the change in speed to go from its initial speed to rest is going to be, well, ignore the signs for deceleration or anything like that. So M is 0.5. So it's going to be 50 over 0.5, which comes out to be about 100 meters per second or thereabouts, depending on your answer. So I'm looking here to see if you did the substitution. If you got something in the region of 100 meters per second, which is very, very fast indeed, that's a couple of 100 miles an hour. That's rather fast, but that would give you the correct. That would be correct. Remember, I'm always looking for technique rather than just the answer. Right, nearly there. Now we get on to slightly harder questions. We're now into sort of distinction level sort of work. So question number 6: explain what's meant by centre of gravity. Well, when we did moments, we talked about centre of mass and centre of gravity. So it's a definition. If you don't know it, look it up, learn it. It is the point in an object, or the point at which all the, well, it's gravity, so it's going to be the weight of an object can be said to act, okay? So basically, if you said the point at which the mass of the object can be said to act, you'd get 1 mark. I gave you 2 if you said the weight of the object, okay? So it's the basic definition. If you remembered it was weight and not mass, you get your 2nd mark. Dead easy. Define the moment of a force. Now, some people got really confused by this. If you've got a definition, sometimes it's okay to define something using a formula. You know, the moment is force times perpendicular distance, and it's worth 1 mark. So you don't have to give that great big long definition that I've given you before, that I gave you last term. There, and is in your student guide. You can give a slightly abbreviated version, but you have to do it in words. So it's the force multiplied by, and I'm looking for perpendicular distance, not just distance. Force times distance would be the definition if you're, if you're doing your GCSEs. I'm not going to accept it for foundation level, for university foundation level. It's going to be perpendicular distance. You could say perpendicular distance between the line of action of the force and the pivot if you want. And if it was 2 marks, that would be required, but this is only 1 mark. So that's all you really need. Okay, so if you're giving a definition, some definitions you can memorize word for word, but if you're completely stuck, think of the simplest formula used to calculate it and state that formula in words, and that can sometimes get you out of a tight spot. Right, this one's quite hard, but actually not as hard as it looks. So students being weighed, the student of weight W stands 0.3 meters from the end of a uniform plank, and the plank's got a certain weight of 80 newtons. It's 2 meters long. It's a pivot at P, so there's your pivot, supports the plank at 0.5 meters from here. It says the weight of 70 newtons is moved to balance the weight of the student, and the plank is in equilibrium when the weight is 0.2 meters away from the end of the plank. So it's a little bit of a complicated question, but we can simplify it when we come to actually do calculations. The first one is 2 conditions necessary for the plank to be in equilibrium. Now, most people see the word pivot and they realize it's a moments question. Well, if that's the case, then we're looking for the idea that the clockwise moment is the sum of all clockwise moments is equal to the sum of all anti-clockwise moments. That's for the first one, but what's this second one? And then you remember, equilibrium is balance. Remember, it does not just moments that balance, it's forces that balance. So if all the forces were balanced, the sum of all forces in all directions equals 0. Okay, that'll do nicely. That's the one that really confuses people, because you're kind of in moments mode, and because you're in moments mode, you kind of forget about linear forces for a second. Easily done. Now you have to then determine the weight W of the student. Now what you do, the technique here is, we all know it's about distances from the pivot. So if I extend my line upwards from the pivot, and I've got my line upwards from the student, I've also got a force downwards here from the weight of the plank and from the weight of this mass here as well. Okay, so we're looking at all the distances from here to the 3 points here. So we've got to think very, very carefully. Well, we know this is 0.5, so this distance is 0.2. I'm not going to bother with units. This is not part of the answer. It just helps me to answer more easily. Now, if it's a uniform plank, the weight of the plank is going to be acting as its center of mass, which is going to be slap bang in the middle. So that's going to be there. So that's going to be from there to there. And if that's the case, well, if it's going to be halfway along the plank, it's a 2 meter plank, it's going to be 1 meter from the end. That's half a meter. So it's 1 meter minus that half meter, means that that's also going to be 0.5 meters there. And then we want the distance from the pivot to the actual weight. It's just a little bit of mathematical confidence, really. Want that distance. So this distance from here to here, well, if that's going to be 0.5, and that's then going to be 1 meter, that would be 1.5, but we're 20 centimeters in, so that's going to be 1.5 minus the 20 centimeters. That's going to be 1.3 meters. Okay. Now, if that's the case, then it's pretty simple. We're looking at everything trying to turn it clockwise, which is this weight here and this weight here, and everything trying to turn it anti-clockwise, which is the weight of the student. So remember the technique I showed you. Clockwise, sum of clockwise moments equals the anti-clockwise moments. Okay, CM clockwise moment, ACM anti-clockwise moment. So the clockwise moments are from here. So that's 80 times 0.5, because all at right angles. plus the clockwise moment from this weight here, which is going to be 1.3 times 70. Okay. And then the anti-clockwise moment is caused by the student with a weight of W and is 0.2 meters away from the pivot. Okay, and then it's a very, very simple equation to solve. If that's a very simple equation to solve, we know that that's going to be 40 plus, well, this comes out to be 91. And then we've got to divide it by 0.2 to get W. So the weight is going to be 655 newtons. That was actually quite a tricky question, but the key there is really being able to recognize what the distances are. So basically, if you got the correct answer, you could assume you can get the benefit of the doubt and actually get the 3 marks. But what I'm also looking for is, did you use the principle of moments? If you attempted to use the principle of moments, that was worth a mark. Then the other mark was actually for working out, working out these distances. If you worked out these distances correctly, that was actually worth your 3rd mark. Right, it says if only the 70 Newton weight is moved, there is a maximum weight the weight of the student can be determined using that arrangement. State explain one change that can be made to increase this maximum weight. There are lots of different things, but basically we're looking at increasing the maximum available moment from this weight. The simplest way to do it would be to move the pivot to the left. Okay. The reason being is if I put the pivot over here, for example, then the moment from the student would be less, and there'd be a greater available moment from the weight. Okay. Okay, but anything that increases the moment that the weight can actually provide, like you could say using a heavier weight, you could say moving the student to the right, that would be fine. So if you increase the moment and you talked about a way of doing that, that was worth your 2 marks. Okay. Right, last but not least is the multiple guess part of the question, part of the paper. Okay. Again, this is multiple choice. People think is easy. It's not always easy. So the acceleration of free fall on a planet is 1/6 of the acceleration of free fall on Earth. So the mass of the body on planet P is 30 kilograms. What is its weight on planet P? Well, it's going to be the mass multiplied by the acceleration, or the acceleration due to gravity, or the gravitational field strength, which is 1/6 of what it is on Earth. So on Earth, it's 9.81, and it's going to be 1/6 of it. Okay, so the answer is 49 newtons. 1 mark for each question here. This one really got some of you. 4 students made a series of measurements which could be described as precise but not accurate. Precise means they're close together. Okay, so we're looking at values which are reasonably close together. So here, this is not necessarily precise because they're quite, there's quite a range here of values. And again, here, massive range of values, definitely not going to help. Okay. So this one, again, this is actually these are reasonably close together. But if you worked out the average comes out to be about 9.82. And it wants ones that are not accurate. So the actual accurate value, the actual value was 9.81. So this is very, very close. So this is actually accurate and precise. So this one must be the answer. Well, if you look, they're all pretty close together. They range from about 8.41 to 8.50. So they're pretty close. They're of the same sort of order. But if you were to average them, you'd have a value of G which was way out. So they're precise because they are close together. They're not accurate because when you take the average, it's a long way away from the accepted value of 9.81. So the answer was D. A body falling in uniform gravitational field encounters air resistance. The air resistance increases until terminal velocity is reached. Which factor does not affect terminal velocity? Remember, the terminal velocity is the point at which the weight of the object is balanced by its air resistance. Okay. Well, if you had very dense air, you would decrease the terminal velocity because you have to push more air out of the way. If you had a body with more mass but the same size, its terminal velocity would increase. If you made a body flatter, it might have a decreased terminal velocity, but it doesn't matter what height the body falls from, it would have the same terminal velocity. It's just that if the height was very, very small, it might not reach it yet. But the terminal velocity is an actual constant value for an object falling through the atmosphere. So B was the answer. Nearly there. Number 10. Which one is not Newton's laws of motion? This one, again, I think confused people because all four statements are actually correct, but it's asking which ones are not Newton's laws. So, for example, here, a body continues in a state of rest or uniform motion in a straight line until it's acted upon by some external force. That is a law of Newton's first law. If a body A exerts a force on body B, then body B exerts an equal and oppositely directed force on body A. That's the third law of motion. Every action has an equal and opposite reaction. The rate of change of momentum is directly proportional to the external force acting on the body. That is the second law of motion. It links to F equals ma. So this law here is correct. The total momentum of a system of interacting bodies remains constant, providing there are no external forces. That's correct, but it's not Newton's laws of motion. It's the principle of conservation of momentum. So A is the answer. And what is meant by the weight of the object? This is quite a tough one. This is all about accuracy of language, this one. So what is meant by the weight of the object? The gravitational field acting on the object, well, that would be linked to its weight, but it's not really the correct term. It's the gravitational force acting on an object, okay? Because if we look here, the mass of the object multiplied by gravity, well, if I said mass of the object multiplied by the gravitational field strength, then I would give that. Then you could say that was the weight of an object, but it's not very well worded, so it's not really right. The object's mass multiplied by its acceleration. If it said it's acceleration due to free fall, yes, but it just said it's acceleration. Acceleration of what? Down a slope? As it's accelerating because it's being pushed by a jet? I don't know. It's not clear. The only one that's very clearly and very precisely the definition of the weight of an object is B. Okay? Right, your work to do over for the rest of the lesson, the last 20 minutes, and over the weekend. Listen carefully. Hopefully, as I mentioned at the beginning of the lesson and in Show My Homework, you're going through this together and you're marking to see how many marks you got. Okay? What you need to do first of all is you need to put in comments on Show My Homework or on Satchel. You need to put your mark out of 75. I'd like to mark it and put your mark out of 75. You then need to identify the topics where you lost the most marks. So for example, if you lost most of your marks in question 6, then that would mean that your weakest area was that your weakest topic in that exam was the moments question. If you lost the most marks if you lost a lot of marks in question 1, then that's all to do with measurement and uncertainty. And I'd like you also to put that into your comments. So you put it in as 2 separate comments. The reason being is that when I come to look at assessing you, I want to see what areas I think I need to go over with you in the latter part of next week. So next week on Tuesday, I'm going to give you an exam to do. I'd like you to do it under exam conditions and submit it. You must submit it next week. When you do that, I'd like to submit it as if it was the real exam. So take photos, turn it into a PDF. As I've said before, if you're currently in Brookhouse College and you need some graph paper, give us a shout. Or you can actually just, if you're in Brookhouse College, if you email it to reception@brookhouse.com and ask Miss Lisa to print it out, to print this out for you, she can do that for you as long as you come and collect it in the main building. If you're at home, then I advise you to print out the paper and try and answer the questions. If you really don't have the wherewithal to print out, not a problem. Take a piece of paper and just clearly state which question you're answering next to your answers, and you can take a photo of that and send it to me. That will be next week, but this week it's adding up your marks, see what you got out of 75, and also then adding up your and then also identifying the topics where you most need me to go back over the key points on it. Okay, everyone, thank you very much for taking part in this. I have recorded this, so I will convert it into a video file and then we'll post it up on YouTube as soon as I possibly can. Thank you very much for coming. Any questions at all? No? Okay, well, thank you very much for your attention with this. Hopefully nobody's just logged into Zoom and then turned the sorry, hang on, I'll stop recording.